Hello viewers, welcome back to my channel enginiusmechtech. I hope you're all doing well and waiting for my video. Today we are starting our chapter sheet metal working. Sheet metal working includes cutting operation, bending operations, drawing, other sheet metal forming operation performed on the presses, dies and presses for the sheet metal processes, other things like sheet metal operation not performed on presses, and bending of the tube stock. First of all, what is sheet metal working? Sheet metal working includes cutting and forming operation performed on relatively thin sheet of metal, as it is clear from name that it is like thin sheet of metal. Thickness of sheet metal lies between is approximately equal to 0.4 mm or 1 over 64 inches to 6 mm or 1 by 4 inches. What is different between plate and sheet? The thickness of the plate stock is greater than 6 mm, and the things that are less than 6 mm is known as sheet. Operation usually performed as cold working. As you know, sheet is thin part, so there is no maximum force and no more force required for the deformation, so we can perform as cold work. Product include sheet and plate metal part for consumer and industrial product such as automobiles, airplanes, railway cars and locomotives, farm and construction equipment, small and large appliances, office furnitures and computers and office equipments. Advantages of sheet metal parts. Sheet metal parts have high strength, good dimensional accuracy, good surface finish, low cost. For large quantities, economical mass production operation are unavailable. So these are some qualities. There are three major categories of sheet metal processes. Number one is cutting. Cutting is basically shearing force or shearing processes to separate large sheet or cut part perimeters or make holes in the sheets. It is like shearing that tear some part. Bending, straining sheet around the straight axis. Actually, bending, as you all know, it is turning, applying force on some part, some metal sheet for some time, and remain it into the same place. Drawing is actually forming of sheet into convex or concave shaped. It is like forcing something or pulling something. We will discuss it later with visualization. Sheet metal working terminologies include there are punch and die. Die is the required shape and punch is the force acting agent tool to perform cutting and bending and drying. Stamping press is a machine tool that performs most sheet metal operation as opposed to just press used for forging. As the press is used in case of forging, we already discussed, it is the stamping process. Sheet metal products, etc. Now, first of all, what is cutting? It is shearing action between two sharp cutting edges. This is visualization. This is the punch and this is die. When the punch is come downward, it apply forces on it and then just before, and this is the position when just before touching the sheet. This is the second step when the punch is pushing the sheet. There is some kind of deformation, this is plastic deformation, and the sheet is slightly bent, causing plastic deformation. Now punch compresses and penetrates into the work, causing smooth cut surface. This is the penetration and cutting surface is formed. The penetration zone is generally 1/3 of thickness of the sheet. Now this is the main thing. When the fracture is initiated and propagate for the purpose of separation, this is actually the fourth step, and then it's completely separated in the next part. That's the rollover, burnish and fractured zone. So next is shearing, blanking and punching. Basically there are three principles operation in press working that cut the sheet metal. First is shearing, second is blanking, and third is punching. Shearing. Sheet metal cutting operation along a straight line between two cutting edges. In a straight line between two cutting edges. Typically used to cut a large sheet into smaller section for subsequent operation performed on machine called power shears or squaring shears. This, as you can see in the figure, the shearing punch is designed in a way that, as we can see in the front view, it is the tool is um, down in front side and in a slope and rise in the back side. And when we see in the side view, it also there is a slope. This is a slopy area. Why this happened? This has happened to give the pointing area, that when the area is in the contact is less, then less force is required. So when this area come here, cut the piece, then this, then this, then this, and so on up to this area. So there is very cool and very interesting terminology for process. Blanking and punching. This is basically blanking and punching are two similar things, but there is a little and small difference. And it's a very tricky question for the in according to exam point of view. Blanking, the sheet metal cutting to a separate piece from surrounding stock. Cut piece is the desired part, called a blank. This is a whole sheet when we apply force through dies, and the punch, this is known as blank, and this process is known as blanking when the punched part is the desired part. But when punching is the sheet metal cutting similar to blanking, except cut piece is scrap, called a slug. Remaining stock is the desired part, in this the remaining part is the desired part. This is similar, both is pressed and punched, but in this the second part is the desired part, in this the first part is the desired part. Clearance C is the distance between the punch and the die. Typically value ranges between 4% and 8% of stock thickness. T, if the clearance is too small, the fracture line passes through each other, causing double burnishing and larger force. This caused increase in force. But if the clearance angle is too large, the metal is pinched between the cutting edges and excessive burr results. This is not the clean and tidy cut off. Recommended clearance can be calculated by the formula C is equal to AT, where A is the allowance and C is the clearance and T is the stock thickness. Allowance A is determined according to type of metal. Allowances for the some sheet metal groups for the 1100S and this aluminum alloys, it is A is equal to 0.045. For these aluminum alloys, brass, soft cold rolled steels and soft stainless steel is 0.060. For cold rolled steel and hard, half hard, stainless steel, half hard and full hard is 0.075. This is small clearance, double fracture. This is large clearance, excessive burrs and etc. Punch and die sizes for blanking and punching. For a round blank of a diameter dB, this is basically dB. It is given by blank punches dB minus 2C. This is basically C. If the dH is dB is given, we can find the other one dH, and if the dH is given, we can find the dB just by adding or subtracting two C's, because there are two sides. So one is this C, one is this C, and this is the die, and this is actually the sheet stock. You can see the formula in this dB minus 2C and this d. Angular clearance. The purpose allows slug or blank to drop through die. Typically its value is 0.25 degree to maximum of 1.5 degree on each side. This is basically the angular clearance, this slopy area. And the angle between this and this is typically from 0.25 degree to 1.5 on each side. This side and also this side. Now this is interesting part and important part. What is the force required for cutting? Important for determining the press size tonnage, F is equal to STL. What is the formula? F is equal to STL, where S is shear stress of metal, T is the stock thickness, and L is the length of cut edge. If shear strength is known, F is equal to 0.7 TS STL, where TS is the ultimate tensile strength, T is the thickness, L is the length of cut edge. The L can shear gradually reduce the F required at any instant. This is the example. You can do it for your practice for the betterment of yourselves. A round disc of 150 mm diameter is to be blanked from a strip of 3.2 mm half hard cold steel whose shear strength is 310 MPa. Determine the appropriate punch and die diameters and blanking force. This you can be done by the previous formulas. Please comment in the comment section if you have done and send it to me. I will give you some email in your comments replies. Sheet metal cutting operation is include this type. Cutoff is a kind, parting is another thing. In cutoff, you cut the piece in a way that you can get the desired part in both of the cases. This is basically cutting lines. This and this is the same thing. This is the similar. Parting is that this is the strip and this is the scrap. Part, scrap, part, scrap. This is like slotting in this the extra material and the part. Perforating, it is also a kind of punching operation. Notching and semi-notching. You can see this is semi-notching. This is complete notching. Sheet metal cutting operation include trimming. Trimming is the cutting operation to remove excess material that maybe after the casting process the excess of material that are removed by the trimming process. And shearing. Shearing with very small clearance to obtain the accurate dimension, secondary or finishing operation. This is a kind of these operations. Pressure bed and blanking punch and etc. Bending. Straining the sheet metal around a straight axis to take a permanent bend. Fix this part and bend the other half at some extent at some angle to get the desired shape, desired angle. This is actually the radius, this is angle, and this is neutral axis, W plane. The inner is reduced length and the outer is increased. R is bend radius, bend angle, area. This is A prime, included angle. That is the inner side angle. This is the bend angle and this is the desired angle, and W is the width. Metal on the side of neutral plane is compressed while the metal on outside of the neutral plane is stretched. As you can see, the both lengths are initially the same, but when it is stretched, when it is bent, the outer is stretched and the inner is compressed, and the neutral axis remain the same. The metal is plastically deformed so that bend takes a permanent set with no changes in thickness. Hence, the same thickness is not changed. Types of sheet metal bendings. There are two types: V bending performed with a V-shaped die and edge bending performed with a wiping die. V bending is for low production performed on the press brake. V dies are simple and inexpensive. This is V die. When the force is applied on it, the sheet is converted into the angle that is given in the V. And edge bending for high production pressure pad is required. This is an external part. Dies are more complicated and costly. This is the pressure pad, force is applied on it, and this is the punch. Move here and converts the sheet into the desired angle. Engineering analysis of bending, stretching during bending. If bend radius is small relative to the stock thickness, metal tends to stretch during bending. Important to estimate amount of stretching so that the final part length and is equal to the required specific dimensions. This length is called bend allowances, and it can be estimated as follows. The bend allowance formula is given by BA. Bend allowance is equal to 2 pi A by 360 into R plus KBA into T, where B is the bend allowance, A is the bend angle, R is the bend radius, T is the stock thickness, KBA is the factor to estimate stretching. If R is less than 2T, then KBA is equal to 0.33, but if R is greater than or equal to 2T, then KBA is equal to 0.50. Springback in the bending. This is very interesting and important terminology, springback, as it is clear from the name that spring is something coming back to its position. Springback means coming back to its position, but in this case to some extent. I can tell you, increase in including angle of bent part relative to included angle of forming tool after tool is removed. When the tool is removed, the sheet is come back to original position due to when bending pressure is removed, elastic energy remains in the bent part, causing it to recover partially toward the original shape. This is some kind of a strain energy that is included in it. It's elastic energy. When the force is applied, this is initially the AB angle and R radius. But after the force is removed, sum of the angle is increased. This is high angle, and radius is also increased. This is the, and it is come back to here. Springback SB is equal to A prime minus AB prime divided by AB prime. The amount of springback increased with decreasing modulus of elasticity and increasing yield strength of the work metal. Compensation for springback. Overbanding. The punch angle and radius are fabricated slightly smaller than the specified angle on the final part so that the sheet metal spring back into desired value. This is just like the allowances if we increased it for the desired part, just like that. What is the bending force required? It is given by F is equal to K BF T S WT square divided by D. Here F is the bending force, TS is the tensile strength of the sheet metal, W is work width in the direction of bending axis, T is the stock thickness. For V bending, the KBF is 1.33, and for edge bending, KBF is equal to 0.33. D is the die opening dimensions is given in the next figure. This is the D given previously, the D. And here in this case, this is the D. In the bending operation, this is the straight flanging, stretch flanging, shrink flanging, hemming, seaming, curling, beading. These are all the types of bending operation you can see. This is straight bending, this is slightly curved, hem, completely curved,